This is Dirk Zhao. Today we're doing question 3 from 2017 exam. This question shows us a graph of f prime of x on the closed interval -6 to 5. And it also tells us it's the key factor that f of -2 is equal to 7. So as we see the question, we kind of get a sense of this question is going to ask us about derivatives and antiderivatives and the definition of antiderivative, which is the area under the curve under f prime of x. So let's look at the first question together. Question A. Find the value of f of -6 and f of 5. So we know that f of -2 is equals 7. So we know f of -6 by definition is f of -2 plus the integral from -2 to -6 of f prime of x. And because -2 is actually greater than -6, we're integrating from a higher value number to a lower value number, so we can flip the bound and then drop a negative sign in front. So we got f of -2 plus -6 to -2 f prime of x. So what is f of prime of x from integration from -6 to -2? As we said, the integration, the antiderivative of f prime of x is the area under the curve. So we have this yellow triangle to be our integral from -6 to -2 of f prime of x. So we knew that f of -2, excuse me, is 7, plus we have negative, we know the area of triangle is base times height, so we have 4 times height 2 divided by 2. That gives us 7 minus 4, which is 3. So that's f of -6. Similarly, f of 5 is actually f of -2 plus integral of -2 to 5 f prime of x. However, this time we're not only dealing with one triangle. F of -2 is 7. However, as we can see, this yellow triangle does not include in this formula, but the blue triangle and the green semicircle is on the interval from -2 to 5. So we want to add up those two areas. So we have negative because this semicircle is on the negative of y-axis. So it gives us a negative value, adds up to f of x. So we have negative a half pi r squared. So half pi, we have r equals 2, squared is 4. And then the blue triangle, we plus because it's on the positive y-axis, that gives us positive value, add up to f of x. That gives us 3 times 2 divided by 2. So base times height divided by 2. So we got 10 minus 2 pi. So pretty straightforward. Alright, question B. On what interval is f increasing? Justify your answer. So when we ask about f of increasing, we knew that if f of increasing f prime of x needs to be a positive value, needs to be positive. So when we look at the graph of f prime, the only part, the interval when f prime of x is positive, is from -6 to -2 and from 2 to 5. So on the interval -6 to -2 and from 2 to 5, f prime of x is positive. Therefore, f of x is increasing. So question C, find the absolute minimum value of f on the closed interval -6, 5. Justify your answer. As we first look at question number C, there are 3 possible minimum of f on the interval -6 to 5. First of all, the 2 endpoints are definitely 2 possibilities. However, another possibility may occur 1x equals 2, because that's 1 f prime of x goes from negative to positive. However, when we look at the graph, there are 3 possibilities, 2 endpoints, and 1x equals 2. However, the 2 endpoints, the 1x equals 5, the other x equals -6. However, we can immediately eliminate this because f of 5 is when f of 2 minus the green semicircle and then plus the blue triangle. So this area is definitely going to be less than f of 2. Therefore, this we do not even need to testify. However, we do need to test the endpoints and when x equals 2. The endpoints we already did for question A. We got f of -6 is 3 and f of 5 is 10 minus 2 pi. And it is indeed very easy to find f of 2 because it equals f of 5 minus the blue triangle, which is 3 times 2 over 2. So we have 7 minus 2 pi. So we can find out f of 2 is less than f of -6. Therefore, f of 2 is our minimum. Moving on to question D. So find each value f double prime of -5 and f double prime of 3. Find the value or explain when this does not exist. So we have the graph f prime. To find f double prime is actually finding the slope at that point. So we're trying to find the slope of f prime at x equals -5 and x equals 3. So when we first take a look at f double prime of -5. So at -5, we're on a straight line. And we just need to calculate the slope of this line. So for the slope rise over round, we have 2/4, which gives us 1/2 to be f double prime of -5. And when we take a look of when x equals 3, the slope, so it is interesting to see when x equals 3, we actually have a corner where this function is not differentiable. So the function f is not double differentiable at x equals 3. So we will say f double prime of 3 does not exist. And the reason for that is there is a corner and f prime of x is not differentiable. So that concludes our lecture today. I hope everyone got a very good score on the 2017 exam, and keep learning. I will see you next time. Bye.